permission to start the record? All right, thank you. All right, so welcome everyone to ACDT number 78. Today is April 20th. Mainly we'll focus on discussing DevNets today. So yeah, let's just get started. And the first topic is blob DevNets, DevNet 0. And I think Barnabas, that's your domain. Do you have an update on this?
There's no currently any updates. I think most of the CL teams are focusing on shipping EPBS. We currently have still just Prism and Lighthouse deployed on them. Last week we have enabled partial sales on every single node, and we're experimenting with that.
All right, thanks. Any points to be raised by any of the client teams regarding blob DevNets?
It would be good to start onboarding other clients here as well.
Which are the ones that are currently joined the DevNet, and who is missing?
It's Prism and Lighthouse only. Everyone else is missing.
All right, anyone from Nimbus, Lodestar, who want to chime in?
Yeah, for us, there's still a few pieces missing. We need to get done probably this week.
All right, thank you. Anyone from Nimbus? This is blob DevNet 0, by the way.
Oh, never mind my comment. I was thinking EPBS DevNet.
Oh, I see. Got it. All right, I don't think there's anyone from Nimbus. Should we jump into the next topic then? Or Barnabas, do you want to
Yeah, we can
raise
move
any
on.
other points? All right, thanks. Yeah, let's move on straight to blog level access list DevNets. There was a comment in the agenda today by Marius that he suggested that we should jump directly into Glamster.DevNet 0 instead of going to blog level access list DevNet 4. So Marius, would you like to expand on the topic?
Give me a second. I'm in a room and my fiance is also in a call. So. Okay, so basically what we want to do is we want to move to a world that has all of the changes for Glamsterdam as soon as possible. And there's two ways of doing it. We can either go to Bell DevNet 4 or we can go to Glamsterdam DevNet 0. What we would gain by going to Bell DevNet 4 is that there is a it's like regardless of whether EPBS is happening on the consensus layer, we can continue testing stuff on the execution layer. But what we can instead also do is just go to Glamsterdam DevNet 0 and then get an old version of the consensus layer to create a network based off of that if we feel like the consensus layer is not ready for Glamsterdam yet. Yeah.
So Barnabas, you have the other suggestion, right?
Yeah, so basically we want to make sure that the EPBS branch is as stable as possible. So we're not going to be doing any kind of fuzzing yet in the early days of Amsterdam DevNet 0 for sure. So if you want to do fuzzing and benchmarking and stuff like that, I think that should be done on Ball specific DevNets, like Ball DevNet 4. And ideally, Amsterdam DevNet 3 should be based on top of Ball DevNet 3 plus the PR 770 from execution APIs.
Yes, Potus?
I want to support what Barnabas is saying. I think the Glamsterdam DevNet 0 should be thought of as an EPBS DevNet. It's not going to be stable, and it doesn't matter for us that it's not so stable. And it doesn't matter if block level access list wants to be testing like new features on that DevNet, because it's very unlikely that we're going to be hit with problems that are going to be more complicated for us to debug. But I suspect that for EL devs, debugging on an unstable consensus chain is going to be much more complicated. So my advice for EL devs would be to just have a second, just purely EL, just purely BALS DevNet, while we test consensus on the Glamsterdam DevNet 0.
Okay, Tony?
Yeah, or I can also just echo that what POTUS just said, and also what Barnabas said, just with one small caveat, because Barnabas, you said we should then build GLOAS DevNet or Glamsterdam DevNet 0 on top of BAL DevNet 3, but we are currently working on BAL DevNet 4, so I guess you mean we build on top of BAL DevNet 4, right?
No, because I don't want any 8037 havoc on Amsterdam DevNet 0. That's why I would propose.
But we have it on DevNet 3 already.
No, those are using static
is
values. Yeah, but those are using the static values, not the dynamic ones. And as far as I know, the dynamic values are the ones that like require a huge rebase on all the execution layer clients.
No. That is just changing one value. I'm doing a rebase because we've merged some stuff into master and reworked some of the stuff. That's why we have to do rebase. It's not because of the dynamic value for 8037. Basically, like the whether it's a static or a dynamic value shouldn't make a big difference. The calculation is pretty easy. The bigger point is whether is whether 8037 is correctly implemented, and that is testable regardless of what the cost per state byte is.
All right, but then could maybe Dragon mention what he means under disruptive changes?
Maybe that's true for GET, but for REVM, we still need to implement those dynamic changes. And there's additional like 4 or 5 additional changes that needed to land on the state guess. So yeah, there's multiple changes that need to be done.
Yes, like there are changes that need to be done also for the GET side for DevNet 4, but like those are not super dramatic, I would say. Anyway, like it seems like everyone is for making DevNet 4 the next thing for BAL DevNet 4, but I think we should not make Amsterdam DevNet 0 based on BAL DevNet 3. That would be a pretty huge mess for us.
All right, let's do Maria, then Tony, and Spencer.
Yeah, I think I was just going to add that the complication on the dynamic cost was mostly around the test. So the Steel team had to rework a lot of the previous tests to be able to take these dynamic costs into consideration. And my understanding is that most of the work there has been done. Then I would agree with Dragan. So we do have some spec changes between BAL DevNet 3 and BAL DevNet 4. But I feel, I don't know, it's still up to the clients to decide, but I think it would be easier to manage to just have BAL DevNet 4 and then have Glamsterdam feed from that development branch, because implementations will be slightly different. And so it's a bit weird to be using like old implementations of 8037 in the interop DevNet, and then on the side have like continue to work on the new specs. But yeah. happy to also hear your thoughts there.
Tony?
Yeah, I agree with that, what Marius and Maria just said. We should do DevNet 4 and then have the first Amsterdam DevNet also use DevNet 4 instead of doing DevNet 4 and then have the first Amsterdam DevNet basically go a step back and be a DevNet 3 implementation.
Spencer?
Yeah, I guess from my side, I think it depends how quickly do we want to test a Glamsterdam DevNet. If we just want to quickly test the integration between the EL and the CL, then using Bal DevNet 3 feels good. But if we want to use Bal DevNet 4, then it means the first Glamsterdam DevNet's probably going to be delayed, probably towards the end of next Friday.
I think at least timeline-wise, we should definitely be aiming for late this week or early next week, because if we have stuff in person, then it's going to be most productive if we're not waiting till the end of the week to have a DevNet.
Exactly. And that's why I proposed that we would do Bal DevNet 3 instead of Bal DevNet 4. Like, we ideally want to start Kutas' DevNets today.
But Barnabas, we have most of the changes for Bal DevNet 4 already. And like it takes us another day or two to get a version of Bal DevNet 4 done for all clients. And then it makes no sense to test a version of 8037 that is like, I don't know.
But
in
then
our
where does
case,
Spencer's timeline of end of next week come from if the changes are 1 to 2 days?
I don't know. Like definitely for us, it's not 1 to 2 days. It is 1 to 2 days. I need to do a rebase of the stuff, and then I need to implement the 7 changes that we discussed on top, and that should be done in a day, maybe 2.
I guess I'd add the reason I said be a bit later is just each individual new spec change. So I think there's 7 total to 8037 has added already a lot of extra testing that has taken a while, and I think I mean, maybe we'll be very slick in person, and it'll be very quick for us to iron out all the bugs in person.
Like, do you have tests for Bal DevNet 4 already?
No, not yet. I was hoping to have a
Okay.
release out for this call, but yeah, we're still ironing out some of the 8037 changes. But yeah, I think we're just filling the tests now and trying to fix the remaining changes. Yeah, and I think most of the fixes are due to the dynamic cost per state byte addition. But we're close. We're very close.
Yeah, Stefan?
Yeah, I would also propose to launch Bal DevNet 4. We can have it very short, but then to give clients to iterate a little bit, and then quickly afterwards launch Glamsterdam DevNet 0. That would be my suggestion. It doesn't have to be very long-lived, but just to get some fixes in, and then focus on Glamsterdam DevNet 0. Or we can have both running then at the same time as well.
My main question would be, is there any other EL team that feels sufficiently ready, basically, to have DevNet 4 changes in a feature branch?
I guess the question is by end of week, right? Or what's the timeline you're now thinking of, Barnabas?
Well, I'm trying to do local Kutas tests before we launch DevNet, so that usually requires at least another day. Ideally by Wednesday. If we would have, like Mario said, that they should be ready by Wednesday, so that's why it would be good to have at least another client also by Wednesday.
We'll have tests out by the end of today, at the latest early tomorrow. Yeah.
So to add up to that, I think we can reduce the number of tests by reducing the coverage if something does not go quite smoothly. But we'll try to have something by tomorrow for DevNet 4, ball DevNet 4.
Instead of reducing the number of tests, can you just undo the dynamic state cost thing? Because like that would be for us very easy to test. We would just undo that change. We would run all of the tests. All of them would be passing, and then we would just redo the gas cost change, and then like if this is the issue with why the tests are not published yet, then I think that should just be undone, because as I said, I don't see many issues happening with that. While the behavior changes that we are doing to 8037 are more complex and would require like specific test cases.
I think we'll be able to get them in. Like we're basically there. Yeah.
Just to be clear, DevNet 4 spec. Are we all on the same page? All teams? All right. So just to reiterate, we're aiming DevNet 4 spec for block level access list DevNet 4, which will become Amsterdam DevNet 0. Is that correct? Barnabas or anyone else?
Yeah, I'm still waiting for at least one more client to speak up about it. Because last week we were still hearing a bunch of people that were doubting that they could be even done by end of next week, which means end of this week.
Can other clients comment on this? How about Nethermind, Besu? Yeah, Besu, please.
Yeah, I think as long as we get the test, we could be ready. So I mean, we have most changes prepared in draft PRs basically. I'm a bit afraid of the 8047 changes without tests because those are easy to get wrong. But I think if we get those, we should be ready. Yeah.
Yeah, in that case, we can definitely do DevNet 4 with the two new EIPs and the dynamic changes plus plus the PR from 770, which we should discuss next, I think.
All right, before we jump into that PR, any other EL clients with objections to the current spec that we are aiming for? All right. If not, I think just to reiterate, we're aiming DevNet 4, so full 8037 for DevNet 4, and this will become Amsterdam DevNet 0. And the last PR to discuss would be the execution APIs PR. So let's discuss that. I just linked that in the comment, so for everyone to see. Who is in charge of this PR? Who can give us an overview?
I can give an overview. Can you hear me?
Yes, perfectly.
Yep.
All right. So this PR basically changes the behavior of EL when CL is like kind of in sync and way behind the head that EL is aware of. Previously, if CL sends the head block, that EL already has validated a lot of time ago. In the case when this block is from the canonical chain, it's ancestor of the head that the EL awares of. Basically, the spec was saying that in this case, the fork choice update can be skipped. And in the case when it's skipped, there is no payload build process triggered. And yeah, that was before gloss and worked before gloss. But now since gloss, we need to build payloads and we need to revoke out payloads canonical, like from the canonical chain, from the point of view that EL thinks that it's canonical, because it was previously pointed out as the head. So we need to revoke back to like ancestor of the head of canonical chain and be able to build payloads on top of ancestor of the head of canonical chain. Yeah, that's what this PR is about, and also it introduces some limitation on how deep this reorg could be, which is 32 blocks basically. And yeah, but this limitation only matters for the case where we do reorg from the head of canonical chain to one of its ancestors, but not to any other kind of reorgs.
Marius?
Yeah, so I like this PR. It's a 5-minute thing for every client to change. Basically, the way we have discussed it in the guest team is so the way why we had this rule not to reopen the head block was in order to get to filter out faulty or late messages from the CL that would basically show a weird state to the user by going one block back. What we're doing here now is just to track more closely the fork choice of the CL, and we hope and we trust that they're not doing weird things with it. So yeah, but this is anyway an assumption that we have. So yeah, this should be really a no-brainer. I've implemented it twice today, and in within 10 minutes. So I think every client should be able to do this. Yep, that's it.
Yeah, Patus?
Yeah, so I think the phrasing on the PR of like the block, the limits being 32 blocks for this reorg, it's off. Ideally, what EL clients should support is a reorg up to the finalized hash. And if clients cannot deal with very deep reorgs, that's fine. The spec says that you should be able to support up to the finalized hash. And if you can't, then just put in your implementation some limits that are reasonable for the implementation themselves. But I think it's not correct to have the specification allowing for this sort of reorgs up to any fixed number of blocks.
I think it's not like fixed. I mean, yeah, it could be any number, but I think we need some sane limit and finalized, reorg back to finalized. Yeah, I'm just, it's up to EL implementation. So what do they think about it? And for instance, what happens then? The question: what happens if EL does not support a reorg of 10,000 block depth? What should it return in this case? Probably it should be an error or something like
it would
that.
be fine because it's only on the proposer side. If you're proposing locally, you're self-building and your EL cannot support this, then you will fail just proposing your local block. But you can just still take bits and you can still propose a block. And for anyone else in the chain, it doesn't matter, because if there is such a long reorg, anyone else that actually gets that payload will see an honest reorg, not one of these going back to head. So it only affects the proposer side and in the self-building path. So I just don't see any reason why we shouldn't just put there that you should be able to reorg up to the finalized hash.
then what will happen? I don't know.
Then you get a block,
Yeah.
and then you have a branch. And that's just the usual case in which the EL should be able to support a reorg up to the finalized hash. That happens today.
Right.
So EL today should be able to reorg up to the finalized hash.
Yeah, just imagine the case where we have a long period of non-finality. And
Yeah, but
then
that happens today. This is today
Right.
the specification.
But yeah, so we had this in the spec, so not do a reorg if the CL like syncs with like the chain, right, with the network, and it tries to catch up with the head, and it sends already known payloads and payload hashes, and yeah, and fork choice updated as well, pointing out to already known and validated in the past blocks by EL. So, and in this case, if there is a long period of non-finality, in this case, EL will have to do a reorg to a finalized block regardless. So yeah, I tried, actually this PR just tries to do something in between, still allows for this optimization, let's name it this way, and allow for reorgs to, you know, if it's like quite close to the head to address the case for a PBS.
Tony?
Yeah, my question was just answered by Marius. So I was curious, like, because POTOS mentioned it's only for the proposer, but I was interested in, yeah, how would this work for a testers? Would they have the state on the EL side available? But Marius just replied in the chat that EL clients would basically need to resync in such a situation. So I guess it's not super smooth if we ever had such a long reorg, because this would mean nodes could not attest timely because they would need to resync in order to get the state of that pivot block.
That cannot really happen. If clients cannot support a 90,000 block reorg, then that chain will not have the attestation weight to actually cause the reorg. So that's, I think we're just discussing over nothing.
Yeah, so I like the limitation to this one, because what we have seen in the past was faulty CLs just feeding us old blocks and causing and then like we ignored them, but this would now cause us to reorg back to old blocks. So I think it makes sense to me to have a limitation there, how deep these reorgs within the same branch can take. And yeah, as Mikhail already said, this doesn't impact how reorgs to a different branch take. Right.
But the things you guys are dismissing the fact that we need to change fork choice to put this kind of limitation, because otherwise we actually might get into sort of like a deadlock. If fork choice is saying you should reorg up to, like, say 64 blocks, and the EL cannot handle this for whatever reason, then the CL cannot advance, because that's what we should be building on top of.
But why would the fork choice ever need to reorg 64 blocks on a chain without any new block?
No. So fork choice would need to reorg on whatever. That's the assurances that we have. We can always reorg back up to our finalized checkpoint. It may not happen. It may be very difficult to happen, but this is what fork choice is. That's what FFG guarantees to us.
You mean like you are talking about a reorg on the same chain back to finalized block without like, you know, introducing a competing block, right?
Correct.
Why would this kind of reorg needed?
Well, because this is what fork choice is. We don't have a proof of fork choice. We don't have a proof that this is impossible to do.
Yeah, I'm just trying to find a
It's
way, you know.
it might be impossible. That's it, that's the whole point. And it's fine if the spec says we should be able to reorg up to finalize, and implementations cannot handle this situation. Today, the spec says you should be able to sync any block on top of an unfinalized block. And that's what the spec says. Actually, the spec doesn't even say that it needs to be, well, it doesn't matter. In principle, clients should be able to sync any block on top of a block that is not finalized. And we just can't handle this. We get DOSed. Therefore, we ignore some blocks. That's just fine. So I don't see why we would put an artificial limitation where clients can just deal with those limitations. As Mario is saying, the clients already are not following the spec, and they cannot handle a reorg that is deeper than 90,000 blocks.
I think they can handle it. They just need to resync. That's the thing.
No, that means
No,
not handling,
no,
because if I don't get an accepted, or if I don't get an valid there, then we just can't be in sync.
Yeah, but that's a thing. We always had this guarantee that the fork choice will never flip as long as there is no other chain, no other block where like it will just not go.
Yeah, but what happens if we're not finalizing for 90,001 blocks, and I just produce a beacon block on top of that one, like 90,000 old block?
Yeah, then
You're telling me that you cannot handle this.
I'm telling you that we cannot handle this, but this is a different scenario from what we've been talking about. Is reorgs within the same chain.
I understand, but the point is that there's already a situation in which the spec says something, which is what ideally clients should do, and what actual clients can do.
Well,
is different.
Yeah. I agree. And the thing is, we can handle 90,000. Guest can handle 90,000 blocks. Good luck trying that with other clients. I think they can handle at most maybe 1,000 blocks if you're lucky. So, and even for us, the 90,000 block reorg takes several seconds, probably minutes by this point.
Marek?
Yeah, so what I wanted to say is that on one point we brainstormed the idea that basically in case of long reorg, because it's really problematic for us to handle such long reorgs, but on the other hand, we can just switch to, let's say, archive node in this case. And basically we will use more storage, but that's it. We will handle this anyway. So this is not fully implemented in Nethermind, but we can do it like this. And I think I agree with Potus that this is what we should do.
So it also kind of implies that the spec since Paris was incorrect about what we are talking now. I mean, like with respect to what we are talking about now. So it should not have this optimization at all. And what worries me is that for some reason we just remove it now, and yeah, we're required to get reorg to back to finalized, which is probably fine if finalized block is not too far from the head. But then what happens if if this starts to if this is the case on some testnet or whatever that we've seen in the past? So I'm just trying to think about potential implications of that.
Yeah, the bigger problem is that we don't have this finalized state until we get to the head. Like we don't know when is the final, or what block is final until we get to the head. And so there's like this. There's many cases where we don't even know where the final block is, and where the finalization point is.
But that's irrelevant in this case, right? Because this is only for a proposer that should be already in sync. And for what it's worth, unless we are under an attack, I think this limit could be just 2. Like we would never need to reorg more than just to the previous block.
Yeah, I agree. The problem is if we don't put a limit there, then and the CL tells us weird things, then we might just not be able to sync because we keep getting like just imagine having two
But that's fine.
CLs.
That's an EL that is already a faulty EL, and you shouldn't be syncing in the case that the EL is faulty. And if the EL is not faulty, then we are under a situation in which we should be reorging. So
No,
it'll cause a deadlock either way.
Just imagine, like right now you can run an EL off of two CLs. Like you have two CLs that feed you different points. You have one CL that is at the head. You have one CL that is at not at the head, that is currently syncing up, and it works because we specifically just ignore all the updates from the one CL that is out of sync. If we don't have this limit, what will happen is that this one CL will go forward. The other CL will tell us, hey, you actually need to go 5,000 blocks back. We will happily go 5,000 blocks back. Then the other CL tells us, no, you have to go 5,000 blocks forward. We will go 5,000 blocks forward. So we will not ignore the blocks from the out of date CL anymore. This is why this limit is there.
It sounds, Barnabas, it sounds like there's needs to be a change in the PR, at least to me. Is that correct?
I don't think so.
Yeah, my opinion is I'm fine with like introducing an error, which will say that we will not reorg, beyond some. And beyond some, some depth, and the EL will just, each EL implementation will pick up own limitation on that. We're going to say that it must be at least till the finalized block, which is which is kind of like for EL finalized means that it actually doesn't know where a finalized block is, right? So it's like arbitrary depth. So we can just have some kind of 90,000 block limit on that or whatever. So yeah, but that's like up to EL client developers to decide on what should be spec'd out there. Again, this PR tries to find a middle ground between the optimization that we had since Paris and the new requirement that Gloss actually has. That's all. If that's going to be an error, whatever, yeah, let's just do it.
All right, can we wrap this discussion and continue on the PR? Does anybody else have any questions about this? All right, the follow-up question would be, is this going to be introduced in DevNet 4? Is this a requirement?
Yes.
I feel like we're leaning towards yes. Okay.
Well, no, it's not a requirement for Bell DevNet 4 because it's not used by Bell DevNet 4. But if we ever want to do EPBS testing on top of Bell DevNet 4, then we would need it. So I would also say that we should do it, but it's not a requirement for Bell DevNet 4.
I'd also say we're probably not stressing this exact path, right? We need quite deep reorgs, and right now we're still doing relatively happy case testing anyway.
No, EPBS triggers this path quite easily.
Okay, cool.
Yeah, we had this issue already on DevNet 1 or DevNet 0.
All right, regarding the requirements, is it okay, Barnabas, that we create the note with the description of DevNet 4 without this PR, and then on Glamsterdam DevNet 0, we add this PR as a requirement for EO clients to be able to join? Okay. Sounds
And
good.
is this implementable by all clients by next week?
This week, end of this week.
Yeah, this should be implementable by all clients by the end of the call, and we have 20 minutes left, so get to it.
All right. Great. So we have agreement. Good. Do we need to break into the breakout rooms for discussions in specifics to block level access and EPBS? Yes, Pontus?
Before any break, I would like to talk about syncing again, just 5 minutes.
Yeah, okay.
Oh, can I do it now?
Yes, please go.
All right, so it's the same thing that I raised on ACD, and I will try to raise it again. I wanted, and no one has returned on us with this. I really want to have some eyes on potentially removing completely the payload envelope syncing, range syncing on the CL. So the question is to analyze the security or lack of thereof from range syncing on the CL side without even requesting the payload envelopes. The CL could perform all of the state transition on the CL side without ever taking any payload, without even knowing if the payloads actually existed. And then when it catches the head, as soon as it sends a new payload, the EL should be able to tell if it's invalid or not. So what I'm proposing is to change the notion of optimistic sync in this setting. So the CL would not even check the block hash of the blocks because it wouldn't even take the payload envelopes. Another problem with this would be that the CL would not verify the signature of the payload envelope because it's not even requesting those payload envelopes. On backfill, if the CL wants to backfill and get those envelopes, then we could do a batch verification of those signatures. So I'd like to understand what is the trade-off space here, because EPBS allows us to sync without ever requesting a payload.
All right. Are you looking for input from the EL, CLs, or what's the approach here?
From anyone, but mostly from the EL, because optimistic sync is something that is quite complicated on clients. And I believe that most of the edge cases had to do with the merge itself. So I believe we can just remove and simplify quite a bit of optimistic syncing. We can just sync without a payload, and when we're on gossip, validate payload just on gossip.
Does it matter for the ELs? Like, as long as you at some point give us a payload, we will be doing snap sync anyway.
Well, so if we trigger snap sync, that would be a big problem. So the security assumption that we do not want to lose is that an EL that had the state at some point and we're just like restarting or whatever it is, we do not want to trick an EL into following a finalized but invalid chain. If this can happen, and if this can happen because of this change, that would be a problem.
Okay, so what you're saying is that the EL is at some point, you shut it down, you restart the CL, the CL does some sync to the head without giving us any payloads, and then it tells us this is the block that you're syncing to, and then in that case, what happens is the EL will go and fetch this data from the network anyway.
Exactly. And today, for example, Lighthouse like fetches it twice.
Yeah, that sounds unnecessary.
Yeah, so what I would want to do is not even fetch it. So not even check the block hash, not do anything on the CL on this, and just give you later when I catch up give you a block and make sure that if this block is a descendant of an invalid block, even if it was already finalized on the CL, I want to make sure that the EL would just tell me this is invalid.
Yeah, I think that is already working.
Yeah.
For us.
But is it like the problem with some concrete EL, or you just want to make sure that that's how ELs work nowadays?
Yeah, so I want to make sure, and I want to have it written somewhere so that we can actually get into agreement. It sounds to me that there is no reason for the CL to keep payload envelopes, and there's no reason for the CL to even serve by range payload envelopes.
So my only comment is that it makes sense to me. It's how Nethermind works nowadays, but the only thing is that it's quite tricky scenario that you cannot easily trigger. So we need to make sure that it is really well covered by tests. And there were some of this were flaky a little bit for us. Because there are many tests in Hive that are checking it that you will return correct invalid hash and so on. So I guess it should be fine generally, what you are talking about.
Yeah, so what I would want, so this is the concrete request. The concrete request would be to EL devs to analyze the situation, analyze what are the security, the problems that this could cause. For example, one that would be dramatic would be if such a situation can trigger all ELs into snap syncing. Because if that happens, then my understanding is that that could trick the EL into treating a finalized but invalid block as valid. And this would be unacceptable.
So
Could you please repeat? Yes, sir.
Yeah, go ahead.
Just Potos, could you please do a recap on why for CL with like in a PBS case it becomes a problem to work
No,
as,
it's not
as
become
before?
a problem. It's the other way around. ePBS allows this today. The CL cannot sync without getting the payload, without downloading the payload, because the payload is with the block. So the way we sync when the EL is not catched up is we verify the block hash. Either we do it or the EL does it for us, and then we continue syncing, but we download the full thing. ePBS allows us to sync without ever downloading the payload, to which we would just no longer verify the block hash. And moreover, we wouldn't verify the signature on the CL side that the payload envelope carries. But I believe that this is safe anyways because of what EL devs are telling me of the way they sync.
All right. I feel we have to park this conversation. Potus, can you coordinate to do a write-up on this topic to see if we can keep discussing it async?
I've already written most of the scenario up, and I've already posted it on ACD. I'll ask to again bring this up on ACD next time. I'm hoping to get someone EL devs to look into this and actually produce some written statement.
Yeah, sorry about the rush. It's that just we have to go into breakouts because we have barely enough time. Is that okay? All right. Yeah, let's try to jump quickly into the breakout rooms. One for ePBS, one for block level access list. And probably if people have more time, we can stick a little bit longer. I know these have already 15 minutes, but let's try to let's try to finish the discussion topics that we have today. Yep. All right. Who's helping today with breakouts?
I think it's Tony and Justin.